Good morning, everyone. Um, we are looking at a new topic in electricity and magnetism. This is called Ohm's Law. Ohm's Law describes a relationship between the current, voltage, and resistance in an electrical circuit. So, nice little picture for you to refer to. Notice the guy with the rope standing on the top is the resistance, what's holding back the current. Um, excuse me, the voltage is pushing. That's the pressure behind the current, and the current itself, the amps, is trying to move through that very small opening. So, what does that really mean in terms of electrical current? Oop, I went the wrong way. So, compare Ohm's law to our understanding of how water flows. Notice the difference in the water flowing in each of these pictures. In the top picture, someone has a hose and they are uh, putting their thumb over the end of the hose to make it spray out really hard. That's a lot of resistance, but there's a lot of pressure behind it, so it comes out harder. In the second picture, you have a fireman who has a kink in the hose. And you all know what happens when you fold a hose and put a kink in it, it stops the water from flowing out. In the third picture along the top, you have a very calm river. There is not a lot of pressure moving that water along. In the bottom left picture, you have a dam. It looks like a natural dam that maybe beavers built. There looks like there's even a little picture of a beaver in the bottom corner. And it's stopping the water from flowing, or at least restricting it immensely. In the middle bottom picture, you have a man-made dam, obviously stopping the water from flowing also, but if you notice, it's pretty strong current at the bottom of the dam, so obviously it's letting some through. And in the last picture, you have a river that is flowing very fast, and it's got a lot of rapids in it. Those are the bumps that the water goes over and creates all that turbulence. So in each situation, the water is flowing differently depending on two things: how much pressure is pushing that water along, and how much resistance there is um, in the pipe of the water. So another way to look at it is looking at a faucet, and you can turn the faucet on and off. And if you turn it on just a tiny bit, it lets out a little trickle of water. And if you turn it, open the faucet all the way, it um, lets out a very large flow of water. So again, it's looking at how much space the water has to travel through and how much resistance there is in allowing that water to go. So the formula is I for electric current is equal to V for voltage divided by R for resistance. What's that mean? Your voltage symbol is, the unit is volts, symbol is V, and of course the variable in the equation is V. What is it? It is the potential energy difference in a circuit, and it supplies the energy needed in a circuit. And if you apply this to water, what is it in water? It's the pressure pumping the water in the pipes. The current is, the unit is amperes or A or amp, and the variable in the equation is an I. Remember, unit and variable are not usually the same, so volts is unusual. And what is the current? The current is talking about how fast the charges are flowing through a circuit. So if you think back to the picture on the previous 2 slides ago, slide 22, that very calm river, that would have a very low current because it's not flowing fast. Whereas the picture right below the calm river is the river with the rapids in it. The water is flowing really fast there. That would have a high current. So the analogy with water is how much water is actually flowing through the pipes. And then the last term is resistance. The unit is an ohm. And notice the symbol for ohm. It is the Greek omega. So get used to drawing horseshoe shapes. And the variable in the equation, though, is an R. What is it? It is what opposes the flow. It's what gets in the way. It measures how easily charges flow in a circuit, excuse me. So with a lot of resistance, then the current does not flow easily. With very little resistance, it flows very well, it flows very fast. So the analogy with the water in the pipes is how wide or narrow or long the pipes are. Ohm's law makes sense if you think about it. More voltage, notice in that you've got the rapids, the river with the rapids in it. So very high current because the flowing is very fast. And then in the very calm river, you have less voltage because it's very low current, very slow. And notice the brightness of the bulb. I know it's kind of hard to see in these images, but the bulb in the top picture is brighter, and the bulb in the bottom picture is less bright. Ohm's law makes sense if you think about it this way. More resistance. Notice the kink in the hose there. More resistance means less current. Less resistance means more current. And again, you have very bright bulbs and not so bright bulb. Oops, jumped a slide there. Ohm's law. According to Ohm's law, current is equal to voltage divided by the total resistance of all the electrical devices present. So if you look at our little diagram, we have our resistance, that's your ohms, and we have our voltage pushing, that's the pressure behind the current, and then your actual current is stuck there. So more pressure, it'll move faster, more resistance, it'll move slower. And there is a video here to watch, which we'll look at in a minute. So the equation, remember that we can rearrange our equation, and this shows you all three possible arrangements. Voltage is equal to current divided by resistance. Current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. So in practice, how does this actually work? Using the circuit diagram below and your knowledge of Ohm's law, calculate the current in the circuit. Use the three-step method. Three-step method, remember, is for step 1, identify all your variables. Step 2, plug them into the equation. And step 3, solve. So in this diagram, you can see, hold on, I will use my pointer. I want it highlight. You can, there we go. You can see we have a battery that has 18 volts. We have an unknown current, and we have a lamp on it, a light bulb, and that has 3 ohms of resistance. So we identified our variables, our voltage, our current that we're looking for, and our resistance. And oop, that didn't work. Okay. Oh, good. So here We have our formula, we have our variables that we plugged in, and then we solve. So current is equal to 18 volts divided by 3 ohms. The current is 6 amps. And notice we have some questions down here. What would the equation look like if you're figuring, if you wanted to figure out voltage or resistance? So here are 3 more problems. Problem 1, problem 2, and problem 3. Notice we're solving for the different variables. Here we're solving for current. Here we're solving for voltage. And here we're solving for resistance. So try these out on your own. There are answers for you to look at, but try them first and then compare your answers so you know. Oops.